It is a 1 mark question of textile testing part. It says cotton fiber length variation can be expressed by option A uniformity index, option B limit irregularity, option C U percent means Wooster percent, option D index of irregularity. So how the cotton fiber length variation is measured? If you have read about this, then it is measured by uniformity ratio. So what is uniformity ratio or uniformity index? So basically uniformity ratio says that the 50% span length upon 2.5% span length. So this is the ratio of, this is the formula for uniformity ratio. So this is represented, the variation is represented, this ratio is known as uniformity ratio, and the entire variation is represented by uniformity index. So option A is the correct answer, or uniformity index. Then now coming to the next question. Now this is also a 1 mark question. It is of testing part. It says a high value of drape coefficient indicates option A limb fabric, option B stiff fabric, option C compressible fabric, option D smooth fabric. So what is drape and how it is related with drape coefficient? So you have read about drape, that drape is a tendency how well a fabric can hang itself. So if it hangs to a larger extent, then the value of drape is very high. मतलब कितना झूलता है वो, this is known as drape. कितना वो कपड़ा झूल रहा है उसमें, तो this is what is known as drape. So basically high drape coefficient means lower drape value. So if the fabric have lower high drape coefficient means lower drape, so it will not hang high, so it means the fabric is stiff. So high value of drape coefficient indicates stiff fabric. Option B is the correct answer. Now coming to the next question. This question says a textile filament records a tensile stress of 0.3 GPa at a tensile strain of 0.04. Assuming Hookean behavior, the tensile modulus in GPa of a filament rounded off to 1 decimal place is. So what you have to find in this 1 mark NET type of question, you have to find the tensile modulus. So tensile, the formula for tensile modulus, what is written as, what is given as tensile stress to be 0.3 GPa, whereas tensile strain is given to be 0.04. So if you know the formula for tensile modulus, it is tensile stress upon tensile strain. Tensile stress upon so if you calculate, it is 0.3 upon 0.04 GPa. If you solve this, it comes out to be 7.5 GPa. So 7.5 is the correct answer. Rounded off to 1 decimal place, it is 7.5. So it becomes your answer. I think it must be clear to you. It is also a very simple question. Now coming to the next question. If the sample size n is 25 and the standard deviation sigma of a population is 2, then the standard error of the means sample mean rounded off to 1 decimal place is, it is a textile testing question of 1 mark NAT. So it is a very simple question. What you should know, what is the meaning of standard error and how it is related with the standard deviation, that is sigma, and the sample size that is represented by n. So if you have read in textile testing, then standard error SE is equal to standard deviation sigma upon root of n. Root n is under root of sample size, so sigma is given out to be 2 and under root of n means under root of 25. means 2 upon 5, that is equal to zero point 0.4. So zero point 0.4 is the right answer, and you have to write it in one decimal place, so zero point 0.4 becomes the correct answer. I think it must be clear to you. Now coming to the next question. This question says that the techniques used for the determination of orientation in fibers from among us the followings are: option P, that is given as first one is birefringence measurement, second one is scanning electron microscopy, third one is XRD X-ray diffraction, fourth one is differential scanning calorimetry. So if you look at which which technique is used for measuring the orientation, so you must remember what are the different types of techniques that are used for measuring different kinds of things. If you look at SEM is used for looking at the fiber morphology, fiber structure at a very small scale. So if we talk about orientation means how well oriented the fiber is. If you look at the orientation, so birefringence and XRD, birefringence measurement and X-ray diffraction is used for measurement of fiber orientation. If you talk about SEM, SEM is used for, as I have said earlier, it is used for the determination of surface morphology. And if we talk about what DSC measures, so DSC is used for the determination of heat capacity of a polymer and thermal transitions of a polymer, including glass transition temperature TG and melting point. So option P and R is true. So which P and R is true in option number B? So option B is the correct option. P and R is true. I think you have understood these techniques are also very important from gate point of view, and you must look at carefully, very carefully. And because every year now and then they ask these types of questions in one or the other format, but the idea remains the same, and these are very direct types of questions in a 2 mark question, and in these questions 1/3 is negative, so do take these very carefully and seriously. Now coming to the next question. The typical shapes of a comb sorter diagram and the fibrogram of a polyester fibers of equal cut length will be triangular and rectangular respectively, rectangular and triangular respectively, rectangular and S-shaped respectively, and S-shaped and triangular respectively. So in this case, the shapes of the comb sorter diagram is used, and fibrogram for polyester fabric fibers, synthetic fibers of the length is equal cut length, means for both the fibers the cut length will be same. So if we talk about equal cut length for polyester fibers, so for comb sorter, if you have read, it is a direct question. So some this type of rectangular shaped structure is formed in case of comb sorter diagram for polyester rectangular, and in case of fibrogram, this triangular structure is shape is formed triangular. So this is the correct option for comb sorter and fibrogram respectively. So match this for comb sorter, it is rectangular, and for fibrogram it is triangular. So I think this is given in option B. So option B is the correct option. So it is a direct typical shapes of comb sorter. In this comb sorter diagram, two things are important. Many times numerical questions are also asked from comb sorter diagram. The dispersion length and the mean length is questions are also asked. And comb sorter diagram, the diagram itself is important. What is the mean length, what is the 50% span length, and so on and so forth. These kinds of things are also important. So uniformity ratio in case of cotton fibers, so uniformity ratio is equal to 50% span length upon 2.5% span length. So these things are also important in this case, so just have a focus on these things also. Now coming to the next question. In classmate system, the yarn fault H2 as compared to the yarn fault C3 is. thicker and longer, thicker and shorter, thinner and longer, thinner and shorter. So before answering these things, you have to know what are the yarn faults and which types of yarn faults are thicker, which are the smaller, which is the thinnest. So if we talk about classy mat classy mat faults. In this, if you say that what are the thicker faults, so A4, B4, C4, D4. So A4, B4, C4, D4 are thicker faults, and also B3 and C3. B3 and C3 also comes in this category, thicker faults. And if we talk about A2, B2, A2, B2, H2, A2, B2, H2, these are thinner faults. So if we talk about this is typically this kind of thing. Here A4, B4, C4, D4, A4, B4, C4, and D4. So if we go down the line, then these are thicker faults, and as we go down the line, then the thickness decreases thereon. So the yarn fault H2 is comparatively the yarn fault H2 is comparatively thinner, but it is longer. So it is about 8.32 long thin fault. So the fault that is H is said to be long thin fault as compared to the yarn fault C3. So yarn 3 is thicker, but it is shorter as compared to yarn fault H2. So which option would be the correct option? Yarn fault in this case, yarn fault H2 we are talking about this. So it is thinner, but it is longer. So option C is the correct option. Now coming to the next question. This question says that if the moisture regain percent and the moisture content percent of a fiber are same, then the value of moisture regain percent is. What is said that moisture regain percent is equal to moisture content percent. It is given in this question. It is also a 2-mark question. है ना? So what we, if you know the formula for moisture content as always moisture regain percent is always greater than moisture content percent, but in this case both are equal if you know the formula, since moisture content is equal to moisture regain percent upon 1 plus moisture regain percent upon 100. So this way, this is the formula for general calculation of moisture content. So if both these values are equal, so at what value of moisture regain or moisture content is this, will this equation be satisfied? If you write 1 to 1 upon 1.01, it will not be equal. So this equation will be satisfied for moisture regain is equal to moisture content percent, just in case if the value is 0. You can put it here. If we put moisture regain as 0, then 0 upon 1 plus 0 upon 100, it will come out to be 0. Otherwise, except 0, if you write any value, then always moisture regain percent will be greater than moisture content percent, irrespective of 0, whatever value you take will this be the case. And if you know what is moisture regain percent, moisture regain is weight of water over oven dry weight of the material. In moisture regain, oven dry weight is taken, whereas in case of moisture content, weight of water upon total weight of the material is taken. So in case of moisture content, weight of water upon total weight of material, total weight of material. Whereas in case of moisture regain, only oven dry weight is taken, so the value of moisture regain, since the denominator is smaller, then the entire moisture regain value is higher. So what will be the value in this question? The value of moisture regain is 0. So this will be the correct option, correct answer. So you can write 0 here. I think you have understood this question, because at 0 only this equation MC, moisture content percent, is equal to moisture regain upon 1 plus moisture regain percent upon 100 will be satisfied. I think it is clear to you. Now coming on to the next question. A woven fabric with area density of 300 gram per meter square tested by strip tensile test method, keeping the specimen width as 5 cm and gauge length as 25 cm. If the breaking load is 900 Newton, then the tenacity in centinewton per tex of the fabric is. So this is a textile testing question. So in this question, the specimen width is given as specimen width is given as 5 centimeter and the areal density is given as 300 gram per meter square. So we can calculate the tex of the fabric. Therefore tex is equal to 3. Tex is yarn count and direct system. 300 gram per meter square into 5 centimeter. We can write it in meter. 300 upon this meter. So meter to meter got cancelled, and if we multiply one this side and one this side, so it will come out to be 1500 gram per 100 meter. If we multiply this and this, so it will come out to be gram per 1000 meters. So this will be tex. So 15,000 tex. It will come out to be 15,000 tex. And also breaking load is given as 900 Newton. Convert it into centinewton. You will get 900 into 100 centinewton. Therefore tenacity in centinewton per tex is equal to 900 into 100 centinewton upon 15,000 tex. Just calculate this. Just calculate this part and you will get the answer. And if you will solve this, then you will get 15 6 times 6. Then the tenacity is 6 centinewton per tex. So the answer is tenacity of the fabric is 6 centinewton per tex. This is the right answer. I think it is clear to you. Now coming on to the next question. A 50 tex yarn with mass CV of 12.5% is produced from staple polyester fibers, each of 4.5 denier fineness. The index of irregularity of the yarns rounded off to 2 decimal places is. So you have to calculate the index of irregularity. So if you know what is index of irregularity is CV mass percent upon under root of n. Under root of n means number of fibers. So just calculate the number of fibers. Number of fibers. If you will calculate number of fibers is yarn tex upon fiber tex. So if you will calculate yarn tex is given as 50 tex And fiber text, it is not given in text, it is given in denier, so we have to calculate this in text. So 4.5 upon 9 divided by text, so text to text got cancelled, and number of fibers will come out to be 50 into 9 upon 4.5, and you will solve 10. The number of fibers will come out to be 100. So index of irregularity, index of irregularity is CV mass percent upon under root of n. Under root of n is number of fibers. CV mass percent is given out to be 12.5, and under root of 100, 12.5 upon 10, it will come out to be 1.25, and you have to write in two decimal places only. So the correct answer is 1.25. I think this question is also clear to you how to calculate the index of irregularity and what is its relation is CV percent upon number of fibers. Since number of fibers has no unit, then you can calculate number of fibers using the formula, the yarn text upon fiber text. In place of yarn text, you can also write yarn denier upon fiber denier. So because the yarns is a greater quantity, since so this it would be in numerator and fiber is smaller, so number of fibers you will get using this formula. So I think it is clear to you. Now coming on to the next question.